All right, we just want to finish up the backgrounding lab. No quiz today. Okay. Your first case study assignment is going to be due in 2 weeks. So the week after spring break. Probably have it due that Friday, the week after spring break. And we'll start working on material in lab for you to finish your second case study assignment, which will be feedlot focused. Haven't exactly put all that together yet, but I will probably over spring break. Then what else? Need to put out an announcement that if you're going to miss the exam, let's try to get that done before spring break. Otherwise, everyone that took the exams won't see their grades until after spring break. So, um, anything else? Graduate students, don't sleep on doing your project. Still got time, but get it done. Exam on Thursday. How'd the math part go? Some good, some bad, seems like. Mixed case. Okay. Um, cool. Well, let's get started. Did I hit record? Yes. Cool. We got all that for posterity. All right. So just gonna pick up where we left off, I think. This is where we left off. So we're just gonna go through and look at some different rations where we're gonna target 2 pounds a day fed for 75 days, 2.5 pounds a day fed for 60 days, 3 pounds per day fed for 50 days. So we're still adding the same amount of weight, but we're doing it over a shorter period of time as we increase the rate of gain, our targeted rate of gain, right? So we're taking a 750-pound steer to a 900-pound steer, and then we're going to look at what does that NEG content of the formulated ration need to be to achieve these targeted rates of gain. Okay, and all these will be at ad libitum intake, and we're going to do that with the same ingredients. Okay, so we're going to target 13 to 15% crude protein. That's going to be above what their typical or actual requirements are. Over, it's very typical of the beef industry to overfeed crude protein. Okay, we're going to look at using prairie hay, sweet bran, steam flake corn, urea minerals. So you look at these ingredients, what's the first thing that's going to jump out to you that we're going to have to change as we go from a slower rate of gain 2 pounds a day to a faster rate of gain 3 pounds a day? What's what are we so what are we changing? What are we going to displace what with what? Roughage for concentrate? Yep, absolutely. Okay. So 2 pounds per day, right here. Average body weight, 825. Okay. Needed an NEG of 38. Okay. We did that with 60% prairie hay, 25% sweet bran, 10% steam flake corn, 1% urea. Uh, we added rumensin 90. Okay. So that needed to be included at 0.02% of dry matter so that our rumensin, that the amount of rumensin we're feeding is around 330 milligrams per day. Okay. Then we had to add all these different minerals to meet our mineral requirements. Okay. But projected average daily gains, two. This animal's going to eat 19.5 pounds a day, and the NEG was 38 megacals per hundredweight. Okay. So for 2.5, we had to go from 60% prairie hay down. We're at 49.1. Sweet bran, I think we kept that at 20. Steam flake corn, we had to increase quite a bit at 28%. However, I don't think we changed much of these minerals. Okay. So this diet's NEG is 45 megacals per hundredweight. So we had to add 7 megacals per hundredweight to go from an animal gaining 2 pounds a day to 2.5. Okay. Um, okay. Let me just make sure. Oh, I rearranged a lot of these. Some of the minerals changed a little bit, right? But not just too much. Okay. So 3 pounds a day. Okay. right here, we had to increase that diet energy to 52 megacals per hundredweight. Okay. So we reduced prairie hay even more, down to 32%. We bumped up sweet bran to 30%, steam flake corns at 35, still have mince at 90, limestone, salt, cobalt, copper, zinc, and urea. Okay. So crude protein wise, we're sitting at 14.4%, but still have an average body weight of 825. Feed them for 50 days to get them to 900 pounds before we transition them to the full finisher. Okay. Okay. Now, can we do this? Can we make a backgrounding ration with just a simple ration? So eliminate a lot of our ingredients. You know, this would be kind of indicative of what people would do in the 60s. They called it the John Deere ration, the good old green and gold ration, corn and alfalfa, and then whatever minerals that are needed. Okay. So we're just going to do this at the 2.5 pounds per day scenario, feed them for 60 days. So what does your NEG content need to be based on ration? I'm going to try to keep it around 13 to 15. And here we just have alfalfa, steam flake corn, and then these minerals, which we can consider being just like a vitamin mineral premix. Okay. So here we have a diet that is 64% alfalfa, 36% steam flake corn. We only needed to add salt, copper sulfate, and zinc sulfate. We're adequate on everything. Our crude protein's 13.3, and our projected average daily gain's real close to our desired. Okay. NEG is 44, which I think was spot on with the other one. Okay. So yes, you can make a ration that meets all these animals' requirements with a very limited amount of ingredients. Okay. So now we're going to go into an example where we're going to look at how can we make these calculations to determine how much dry matter intake an animal needs to achieve a desired level of gain. So a program feeding example. Okay. If we're given type of cattle, the NE content of the diet, targeted level of gain, the question would be, what is the required level of intake that we need to give these animals? How much are we going to feed this animal for them to achieve our targeted rate of gain? Okay. So there will be equations like this on exam 3. Exam 2, I'm not providing an equation sheet, but exam 3, I will provide you all these equations that are needed. You just need to know how to implement the numbers given into those equations to arrive at the correct answer. Okay. All right. Here we have an 825-pound average body weight. Okay. We're going to use a diet that's 40 megacals of NEG per hundredweight. So that 40 NEG is around 67 megacals at NEM. Okay. We're targeting 2 pounds per day. So that is 0.91 kilograms per day. Okay. I may give you these numbers in pounds, but all these equations need to be in kilograms. Okay. All right. NEG required. Yeah. So really you need to break this out into 2 steps. You need to figure out how much feed you need to have to support that animal's maintenance requirements, and then how much feed you need to have to support that animal's gain requirements. All right. So NEG required to achieve 2 pounds a day, which is 0.91 kilograms a day. So that 0.0635 times 374.1 times 0.891 times 0.96. What am I doing there? Why do I have body weight times 0.891 and also that times 0.96? What is body weight times 0.96? Shrunk body weight. Okay, then shrunk body weight times 0.891 is empty body weight. Okay, so calculate empty body weight, put it to the 3/4 power. So that's raised to 0.75 to get metabolic empty body weight. Okay, then this average daily gain on a live basis, 0.91. We need to make that to shrunk weight gain, so we multiply by 0.96. And then we need to convert that to empty body gain, by multiplying that by 0.956. We raise that to the 1.097 power. Okay? So you end up getting NEG required is 0.0635 times 75.6. So that's empty metabolic body weight times 0.82. So NEG required is 3.94 megacals of NEG per day. So we know that 3.94 megacals per day is needed. This diet is 40 megacals per hundredweight, or 0.4 megacals per pound. Okay? So you divide 3.94 by 0.4, and that animal would need to consume 9.8 pounds per day to meet its gain requirements. Okay? So we can calculate how much energy is required for maintenance. So 0.077 times shrunk metabolic body weight. So animals require 77 kcals of NEM per kilogram of metabolic body weight. Okay, so 0.077 times 374.1 times 0.96 to get live weight into shrunk body weight. Raise that to the 3/4 power. 0.077 times 82.5. So this animal would need 6.35 megacals of NEM per day. Okay? 6.35 divided by 0.67. So 67 megacals of NEM per hundredweight is 0.67 megacals of NEM per day, or per pound, excuse me. So 6.35 is the total megacals of NEM needed. Divide that by 0.67. That animal would need to consume 9.5 pounds of diet dry matter just to meet its maintenance. So now we know pounds of dry matter to meet maintenance, pounds of dry matter to meet gain requirements. Add those two together. We need to feed that animal 19.3 pounds per day to achieve that targeted rate of gain of 2 pounds per day. Does everybody follow that? Okay, I will upload examples of these calculations again that we had on last year's exam. I'll upload these calculations, so don't memorize equations, just know how to implement them. Okay? So we can adjust as this animal gets heavier, we can redo this calculation with their updated body weight so that we can adjust our dry matter intake required as that animal gets bigger. Because as that animal gets bigger, will they need to eat more feed to maintain that same rate of gain? Yes, because they're also getting fatter and more physiological mature, going up their physiological growth curve. Okay? Any questions? Okay. So just going through this math again, but instead of 45 megacals per day per hundredweight NEG, we're going to look at it for 50. Okay. I'm not going to read all this out again, but 12.2 pounds of dry matter per day is needed for this animal to gain 3 pounds per day. Okay. 8.1 is needed to meet maintenance requirements. 12.2 plus 8.1 is 20.3. So for that 825 pound average body weight animal to gain 3 pounds a day, we would need to feed it 20.3 pounds of dry matter. Okay. Okay, I just kind of said this already, but these examples are based off of the average body weight for whatever period. So in a program feeding situation, we can change that period length to as short as we want it. We could do it on a daily basis where we're adding 3 pounds to that body weight each day. Or we could do it as the average of a weekly basis. Okay? So, for example, if targeting 2 pounds per day and you are adjusting weekly, then 750 plus 764, so that's 14 pounds added weight. Divide that by 2. That animal's average body weight from day 1 to 7 is 757 pounds. Okay? From 8 to 14 is 771. For 15 to 21 is 785. Okay? We'll have a lab where this program we'll go over a program calculator that make all these calculations for you, and you can adjust your length of period of interest, etc. Okay, so that is that. We're done with this lecture. Any questions for exam 2? Okay. Yeah, I can promise this will be on this exam. What lecture? Lecture 7. Okay, very important to understand. Grazing pressure here on the x-axis. This could also be stocking density. Okay, so as we get animals in the same number of animals in less area, we're increasing grazing pressure. So grazing pressure is literally pounds of body weight per pound of forage. Okay, so if we're increasing grazing pressure, we're increasing the pounds of animal body weight per pound of forage. Okay, as we do that, what's going to happen to diet selectivity? Okay, so as we increase grazing pressure and stocking density, that animal is going to have more competition and is going to be able to be less selective. So if that animal is going to be less selective, what's going to happen to their diet quality? It's going to drop. As diet quality decreases, what happens to that animal's individual average daily gain? Okay. So here at very light grazing pressures, we have maximized our individual animal gain. So gain per head. Because they have maximum selectivity, they're selecting the highest quality diet they can get from that environment. As we increase grazing pressure, diet selectivity goes down. They eat a worse quality diet. They gain less per head. Okay. So increasing grazing pressure reduces gain per head up to eventually we get to a point where there is literally no forage available for that animal to eat, right? And they would have very, very low rates of gain. Okay. Okay. So for net return per acre, we have gain per animal decreasing, but we're adding more animals to that area. So adding more animals to that area is going to increase total gain per acre per unit area up to a point. Okay. Right around here, around moderate grazing, we'll have a maximum in gain per acre. Okay. You get to a point where you have so much grazing pressure that diet quality isn't the only thing that's going to start becoming limiting. You're going to start suppressing dry matter intake. Okay. So that as individual animal rate of gain crashes, the gain per acre will also crash. Okay. Net return is going to be largely driven by gain per acre. So it's going to follow a similar pattern to gain per acre. Okay. Net return per acre is going to be largely driven by gain per acre. So it's going to follow a similar pattern. It's going to maximize around the same point and then tank. Okay. Classically, the optimum stocking rate is where gain per acre and gain per animal meet. Is classically how people will do these research projects to determine optimal stocking rate, optimal grazing pressure in a given environment. Okay? So be able to draw this graph and describe what's happening. I'm looking for diet selectivity, right? The impacts of grazing pressure on diet selectivity, subsequent impacts on average daily gain. However, you're increasing animals, so that gain per acre continues to increase up to a point where overgrazing starts happening and they both crash. Does that make sense? Okay, I can promise you that will be on the test.
Um, same, same group of slides. Could you talk about the shifting of the critical point before it allowed? I think it's that one.
Okay, so uh, does everybody understand critical forage allowance? Okay, so this is going to be species dependent, but as forage allowance, which is forage mass to animal weight, so as we're increasing the amount of forage available for that animal to graze, that animal is going to have more diet selectivity. They're going to select higher quality parts of the plants, but also higher quality specific species within the wider canopy, right? Canopy means the forage mass. Okay. So higher quality, we're going to increase individual animal average daily gain up to a point. Okay. Then that line is going to flatten out. So that break point in this regression is what's called the critical forage allowance. Okay. So here, this critical forage allowance is happening at a forage mass to animal weight ratio of 1. This is for rye and ryegrass. Okay. But it's 3.3 for pearl millet. Okay. Rye and ryegrass pastures are higher quality than pearl millet. So the impact of forage allowance on diet selectivity, it and where it's going to be maximized is going to be driven by the quality of that basal forage. Okay, so the worse quality that plant species is, that basal forage is, the higher critical the point will be. Critical forage allowance will be. Okay.
Which are you calling that a shift to the right?
Yeah.
Is that what you're? Yeah.
Yeah. You will see the break point uh, at a higher value on the X, right? Yeah. And so this paper uh, looked at a whole bunch of different studies and looked at forage TDN on the x-axis and the critical forage allowance on the y and determined this relationship. So as that forage TDN is increasing, the point where that line will plateau gets less. As diet quality increases, the critical forage allowance decreases. Okay? Any questions? Does that make sense? Okay. This also just shows the same thing, right? They didn't use a stepwise regression here, but they calculated the inflection point of these nonlinear point graphs, and the inflection point is related to the forage allowance, right? So the critical forage allowance. So this is a high digestible diet, uh, medium digestible diet, and then a low digestible diet. As that diet gets less digestible, is less quality, that break point happens at a higher value. Okay, it is more the impact of diet selectivity, and I think this should be kind of obvious. The impact of diet selectivity is going to be driven by the overall quality of the above ground forage mass. Okay, as we increase grazing pressure and reduce selectivity, that's going to be less important if that whole sward, that whole canopy is high quality. Does that make sense? Did I beat that horse? Okay, what else? Yep. Okay. Be able to draw and identify these phases and explain them. Okay. So this is not within a year. This is just time after grazing. Okay. So time of regrowth. This is not January to December. Okay. So this could be a 21-day period where this is day 0 after grazing, and then this is 21 days. Okay? So, and it's related to forage mass. Okay? When forage mass is low, so let's say we graze the heck out of it, okay, there's going to be less plant material above ground for photosynthesis. So what does that plant need to do to regrow? If it can't use photosynthesis because doesn't have enough leaf area uh, for to absorb the sunlight. Where's a plant's energy reserves? Roots. So if they don't have enough above ground forage mass to allow photosynthesis to drive that growth, it's going to have to mobilize energy from its roots. Doing that takes time. So it's going to experience in this phase 1 growth a slow rate of gain. However, eventually it's going to have enough forage mass to support photosynthesis. Okay. So that rate of growth, the slope of this line is real fast. Okay. And that's phase 2 growth. Okay. Eventually, it's going to switch between being vegetative, where the plant's main objective is producing enough above ground forage mass to support photosynthesis. Okay. Eventually, it's going to switch from that to saying, I need to throw out a seed head and I need to reproduce. So it's going to become mature. And whenever it switches from vegetative to reproductive, okay, that rate of growth of above ground forage mass slows down. So phase 3 is characterized by, again, a slow rate of growth. Okay? So this is sigmoidal growth curve. Know the difference between phase 1, phase 2, phase 3. Typically, in our grazing management practices where we're going to do graze half, leave half, we are trying to keep that plant in this phase 2 stage of growth because we're trying to maximize quantity of forage that's being grown. Now, a lot of regenerative grazing practices where they will have real intensive grazing and then long rest and recovery periods, they may try to pull animals off when it's in this phase 2, but they won't regraze again until it gets to this phase 3. Okay? So it's all about in a situation where you're trying to keep the plant vegetative in phase 2, you're trying to maximize forage production, you're trying to maximize forage quality so you can maximize gain per acre. In situations where you try to graze it and leave it in phase 2, but don't regraze again until phase 3, you're trying to prioritize soil health, you're sacrificing animal rates of gain, right? But you're trying to support the longevity of that basal plant. Does that make sense? Okay. So this will be on the test. Draw this, identify phase 1, phase 2, phase 3. Tell me what they are. Okay? Sure. What lecture? Did anybody read Daryl Pill's paper? It's pretty good. I'd recommend. All right. Okay. So there are 3 main roles of a stalker backgrounder operation. Okay. Production, inventory, and then market. What do I say? Market balancing role. Okay. Unlike me, you guys remember those. Okay. Production, inventory, market balancing role. Okay. What is the production role of the stalker backgrounder? Yeah. Increase weight, increase frame, increase quality of cattle. We want to increase uniformity. So maybe we can buy cattle at a bargain, put them in more cohesive groups, upgrade these cattle, and then sell them at a premium. Okay. What's the inventory role of the stocker cattle? Okay. So, inventory role, most cattle in the US, what do I say, is like 60% are born February, March, April, something like that. Huh? 75? It's a lot. I don't remember the exact number. Majority of cattle are born February, March, April. Okay. So that means most cattle are weaned in October. Okay. So if they didn't have this, and not only a stalker backgrounder operation to go into, but also a wide range of stalker backgrounder operations where they have a wide range in daily rates of gain, okay, to where you have cattle that exit the stalker backgrounder situation at different body weights, all animals would be finished right around the same time, okay? So the inventory role of the stalker backgrounder is to take this concentrated, really highly seasonal calf production and spread it out throughout the year so that we have cattle that are finished at different times throughout the year. So we don't want to just produce beef in the summer. We want to produce beef year round. Okay. Okay. The last one was market balancing. What's the buzzword colloquial thing I say about market balancing? It's a shock absorber. Okay. So it allows the beef industry to be flexible in where cattle are grown. Okay. Based off market signals. So we looked at the value of gain in a stalker operation compared to the cost of gain in a feed yard. What's that relationship?
Inverse.
Inverse would be negative.
Oh, so my bad.
So positive relationship. So when cost of gain is high in the feedlot, feeders will incentivize stalker productions to grow cattle on pasture so that they minimize the amount of time they're in a feedlot so they can continue to produce beef, but that cost of gain is being applied to less amount of total gain. Does that make sense? Okay. So it balances forage cost and availability, it balances livestock cost and availability, and it balances corn. Or did I say corn? No, what did I say? And corn cost and availability. Okay. So it's balancing these three markets. Okay. Any questions on that? So, what are the three roles of the three economic roles of the stalker industry? And then describe them is a fair question on the exam. Cool. Other questions?
The winter wheat graze out periods, like one for graze out and one for full purpose.
Yep. So first, let's define what that is. What is uh, what is dual purpose?
Like they're gonna harvest for the grain.
Okay.
They're not stocks.
What point of plant maturity do we need to pull cattle off of first hollow stem? Okay. That's usually going to happen around February to early March. Okay. If my slides say something different, go with that. That's off the top of my head. And then, so graze out, we're not going to pull them off at first hollow stem. We're going to graze until that wheat is played out. Okay. So by played out becomes dead, nothing left for them to graze, has a reproductive seed head that is unpalatable, right? Everybody's seen wheat that's ready to be harvested. Anybody seen wheat straw? You can't support much rate of gain on wheat straw. So that's usually going to happen around May to June, depending on where you're at. This is general, but the further south you go, you can move those up. Okay. Wheat will mature at earlier the further south you go.
Then how specific do you want us to get on the the reason why winter wheat's such a small area deal? Because like obviously there's the 4 reasons you told us, but I
Yep.
guess you want to like find those why. Too.
Yeah. So what are the 4 reasons that winter wheat is pretty much exclusively grazed and done dual purpose in Texas, Oklahoma, Kansas?
Uh, Climate, the flies, the soil type, and then the lower overall wheat yields.
Yeah. So can you explain how that might impact, explain why these factors impact why wheat is only isolated to such a narrow region?
Yeah. Okay.
Yeah.
Yeah.
That makes sense.
Mhm.
So the soil type in North Texas, Oklahoma, and southern Kansas is kind of unique in that um, it's not real heavy clay. Okay. So it doesn't have as much soil problems with soil compaction due to grazing. Okay. As other places in the world. So soil compaction due to grazing, as animals are grazing and walking on the soil, that's going to compact the soil and it will make this real hard pan crust that stops water infiltration and makes that plant not able to proliferate as well because lower water capacity, less wet soil. Plants need water and soil to grow. The Hessian fly, okay, when we're planting, we need to plant wheat earlier if we're going to use it for grazing. So that way we have enough forage grown going into the winter months to support grazing. Uh, Farther south you go, the more active that Hessian fly is going to be during sowing times. So you'll have a whole lot more crop failure due to that Hessian fly eating the wheat. Okay. Then climate, farther north you go, you start getting where there's a lot of snow days. When there's a bunch of snow on top of your wheat pasture, you can't do much grazing. It's actually good for uh, non-grazing wheat because it provides insulation from cold weather. Okay. Then when it melts, it provides moisture. And then grazing wheat in a dual purpose situation is going to decrease grain yields some. Okay. So if you have a 70 bushel per acre production system in northern Kansas, that 5% reduction in grain yield is a lot larger monetary impact than a 30 bushel per acre wheat crop in the North Texas, Oklahoma, southern Kansas. Does that make sense? Cool. Other questions? You guys are welcome to leave as you like. I'm happy to stay until the end of class. But if you feel like you don't have any questions, you want to go? What's up? I think it's 70 math points. Do you guys remember from yesterday? Yeah, 80. So 20 multiple choice, and that'll be 60 for a short answer. Other questions? Make sure you guys go through the math examples I put online. You guys are welcome to go. We don't have to just sit and look at each other. Yep. I think I need to download it actually. I'll do that now. I'm glad you said that. Who remembers what day that was? January 29th. There we go. Oh, I got to stop Zoom before I can do it. Other questions, guys?
I have a question.
Okay.
Not sure, like the, but, if we have, like, we missed, some of those quizzes on excuse absences, we just need to email you to get those made up or?
Reach out to Kyle.
Okay, got it.
Yeah. Uh, yeah. There's too many of you guys missing stuff for me to keep track of it all.
No,
So reach out to Kyle. I think he has them opened actually. Maybe they closed today, but yeah, reach out to him. He'll schedule a time to open them. Let's try to get that done quick. If you've missed some like lecture quizzes, try to get done before spring break. Again. That may not be a bad idea if it's not too much trouble. Yeah.
and then I guess if we keep on going through like some of these like lecture study guides and have any questions, we could just reach out.
Yeah.
Okay.
Shoot me an email. Don't message me on Canvas. Actually, it ends up being an email. And then I'll try to respond to that email and it'll tell me it won't work. So,
All right. Thank you.
okay, guys.